Now let's consider how to find the slope of a curve, not a straight line, that should say, because that is a line. It's not a straight line, but it is a line. So that should say not a straight. How to find the slope of the curve, not a straight line. Okay, that's not straight. Okay, so here's our curve. Here it's parabola generated by the quadratic equation y equals x squared. Let's see what we have here. Okay, so the slope of the curve varies as we move around the curve. So there's can be there, can be there, can be there. It varies, okay? But the slope of the curve at this point here, let's say we have a point on the curve at 2, 4. The slope of the curve at 2, 4 is actually the slope of this tangent here, okay? Which just touches the curve at 2, 4. And we can calculate that, but it's very kind of long-winded. So we'll use differentiation. Okay, a shorter way to find the slope of a curve. So what we do is how to find dy dx, which is the slope for the curve given by a quadratic function that looks like y equals x to the power of n. Okay, so if y equals x to the power of n, dy dx is equal to n times x to the power of n minus 1. Okay, so if y was equal to ax to the n, dy dx is n times ax to the n minus 1. So we multiply the coefficient by the value here, and we take 1 from the value there. So we multiply the coefficient of the variable by the power and reduce the power by 1. You'll get it with practice. So let's have a go at differentiation. So if y equals x squared, dy dx is 2 times x to the power of the 2 minus the 1. So it's 2x to the 1, that's 2x. Okay, so y equals x squared, dy dx is equal to 2x. Okay, so this means that basically the slope is 2x if it was in some sort of problem, and that means that if x equals 2, the slope is 4. At x equals 1, the slope is 2. If x is equal to 6, the slope is 12. Okay? This dy dx is known as derived function or the slope function. Okay, and so here's the notation, another type of notation for dy dx. If f of x, remember we could name functions, sorry, before we do that, as f of x equals something, f colon x going to, or y equals. Remember the three ways of naming a function. Well, let's look at if f of x is equal to x squared, then the dy dx version notation of for f of x is f dash x. Okay, and that's the same as dy dx is equal to 2x. Okay. What about functions with more than one term? Because that function is y equals x squared or whatever. That's kind of straightforward enough. Okay. So what about if y equals 3x squared minus 5x plus 4, a quadratic expression? Dy dx is equal to 2 times 3 is 6, by x to the power 2 minus 1 is 1, minus 1 times, because there's a 1 there that you can't see, 1 times minus 5 is minus 5, by x to the power of 1 minus 1, x to the 0, it's not there. Goes, disappears. Because anything to the power of 0 is just 1. Okay? So that's y equals 3x squared minus 5x plus 4. Dy dx is equal to 6x minus 5. What about a couple more examples? Y equals x squared minus 3x plus 4. So dy dx is equal to 2x minus 3, and the x disappears. Okay? And that's the derivative of f of x. Y is equal to x cubed minus 3x squared plus 6x minus 7. So dy dx is 3x to the power of 2, because that's 3 minus 1. By 2 by 3's is minus 6. X to the power of 2 minus 1 is 1, plus 6. And again, that's the derivative of f of x. So assuming that we can find the derivative of dy dx, let's look at how to find the value of that derivative if we're given a value at x equals whatever. Okay, so y equals 3x squared minus 2x plus 4. Find the value of dy dx at x equals minus 2. So if y equals 3x squared minus 2x minus 4, dy dx is 2 by 3 is 6x minus 2. And at x equals minus 2, we just simply plug that where we see x, and we get that the value of dy dx is equal to minus 14. This means that the slope of the tangent to the curve at the point where x equals minus 2 is minus 14. Because remember, dy dx is the slope, okay? And when we're finding the slope of a quadratic expression like this, we're actually finding the slope of the tangent to the curve, okay? Well, that's what we're arriving at. At the point in the curve where x equals minus 2 would be up to minus 14. So here's an example now from page 517 of the book, okay? So we're given a graph. It's a parabola, and it's from the equation or the function y equals 2x squared minus 4x minus 3. Find the slope of the tangent to the curve at x equals 3. How do we do that? We just get the derivative of dy dx, and that's equal to 2 2's of 4x minus 4. At x equals 3, plug 3 in, the slope is 8. The slope of the tangent at the curve, to the curve at x equals 3, okay, is here, is equal to 8. And then find the slope of the tangent to the curve at x equals minus 1, this one here. Again, dy dx is 4x minus 4, plug in minus 1 for x, and we get minus 8. And then at x equals 1, dy dx is 4x minus 4, so it's 4 ones, minus 4 is 0. Why is this? Because x equals 1, that's x equals 1 there. Okay, and that's parallel to the x-axis. The slope is 0, that's a 0 slope, that's the slope, that's the slope value, greater than 0, less than 0, negative slope, and that's 0 slope. Okay, that's why we get 0 here. Now let's talk about tangents and curves. Now just remember that dy dx is the slope of the tangent to the curve at any point xy. Here's a curve, here's a point. The dy dx of this function gives us the slope of this tangent to this curve here at that point. Okay, so let's find the equation of the tangent. Let's find the equation of this tangent. Okay, it's a line. Find the slope of the tangent to the curve y equals 3x squared plus 4x minus 5 at the point 1, 2. So it's where the tangent kisses or touches the curve at 1, 2. We want to find the slope of that tangent, and then when we know that, find the equation of the tangent, because we'll know its slope and we'll know its point, so we'll be able to find the equation. Anyway, y equals 3x squared plus 4x minus 5, so dy dx is 6x plus 4. So at x equals 1, dy dx is equal to 10. So at that point, x equals 1, the slope of the tangent is 10. We know there's a point where 1, 2 on that line, so we can use the equation of the line formula y minus y1 equals m by x minus x1, given that this is x1, y1, to find the equation of the line, and we will end up with the equation line equal to y equals 10x minus 8, or 10x minus 8 minus y equals 0. Either equation is correct.